Once again, good morning to every student. So, our next point is how to implement the previous formula here. So, already we discussed distance formula, distance from the origin, or section formula, area of a triangle. So we are already discussed. Now the one steps we going ahead. For examples, we are some application using on the behalf of exercise. Now that we are taking this question, prove that A, B, C, D is a quadrilateral. Prove it. This is a square. Now square we have already in our minds. In a square there are four sides in a square. All sides are equal. All both the diagonals are also equal in a square condition. If all the sides are equal and diagonals of the square is not equal, then this is a condition of rhombus. If this ABCD is a rectangle, then the opposite side of AB is equals to CD and BC is equals to AD. That is rectangle when diagonal is also equal. And in a parallelogram, if opposite side are equal and diagonals are not equal, then that is the condition of a parallelogram. Already we given such type of notes in written in our previous class to the every student. I hope you have getting that notes. And so now today we are discuss ABCD is a square. So here is we are using distance formula. Now here is A, the distance of AB. This is equals to distance formula we already know, x2 minus x1 to the whole power 2 plus y2 minus y1 to the whole power 2. Using this applications based here, now x1 is 1, y1 is 7, x2 is 4 and y2 is 2. So putting here, this is equals to 4 minus 1 to the whole power 2 plus 2 minus 7 to the whole power 2. This is equals to root 3 to the power 2 plus minus 5 to the power 2. This is equals to root 9 plus 25 is equals to root 34 unit. Okay, this length is root 34. This length, this is. Now then distance formula using BC, then BC in short we write here, this is, then BC minus 1 minus 4 to the whole power 2 plus minus 1 or minus 2 to the whole power 2. This is equals to 25 plus 9. This is also root 34 unit. Now CD is equals to root minus 4 plus 1 to the whole power 2 plus 4 plus 1 to the power 2. This is also root 34. Now AD A B is equals to root 1 minus plus 4 to the power 2 plus 7 minus 4 is 3. 7 minus 4 to the whole power 2. This is also root 34 units. All the sides are equal. These are four sides: AB, BC, CD and AD. All the sides are equal in length. Now, if all sides equal, then there will be two conditions will be here. Maybe it is a rhombus or maybe this is a square. If, but we want to prove this is a square, so we are joined this length to here, or this is joined to here. Now, so there are two diagonal AC. AC is equals to, using here distance formulas, 1 minus 1 minus 1 minus 1 minus 1 to the power 2 plus minus 1 minus 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 plus minus to the whole power 2. This is equals to 4 plus this is 64, that is root 68 unit, or 13 root 2 root 13, either 2 root 17. Okay, this is will be same. Now BD, this diagonal BD. Now BD is equals to DD, this is, or DB, whatever. Now this is equals to root 4 minus minus plus 4 plus 4 to the whole power 2 plus 2 minus 4 to the power 2 is equals to root 68. If here is all four sides are equal, both the diagonal are equal, then this ABCD quadrilateral is a square. This is hence proof for the square. There are 4-5 questions will be created with this manner. Either it is, here is given a rectangle, to prove that it is a rectangle, it is a rhombus, it is a square, it is a parallelogram, or simple quadrilaterals. 5 questions can be created from this single point. Okay, so I hope you can do other 4 part yourself, every students. So I hope you understand this well. Now the next point is, I remove this one. I hope every student is understand now. Next question is, AB is a line segment, and this line segment point P is here and their coordinates is x comma y. We want to find out, and the point P intersect this line AB into two parts in the ratio 2:3. It means m is equals to 2 or n is equals to 3. Here x1 is minus 1, x1 is minus 1, y1 is 7, x2 is 4 and y2 is minus 3. Okay, now there are more questions also written in textbooks. Their coordinates may be different and their ratio is also may be different. Okay, but the question is given in the same manner. Okay, so we using the section formula here, already we proved in previous lecture. So the point of this x using section formula, the x is equals to n x2 plus n x1 upon m plus n, and y is equals to m y2 plus n y1 upon m plus n. We are using these two formulae in this case. Okay, so now x is equals to, here is m, means 2, it means 2 into x2 is 4, then into 4 plus n is 3, into x1 is minus 1 upon 2 plus 3, this is equals to, this is 8 minus 3 upon 5, this is equals to 5 upon 5 is 1. It means the value of x is 1 now. Then y is equals to, n is 2, once again 2 into y2 is minus 3 plus n is 3 into y1 is 7 upon 2 plus 3. Okay, 2 3 ja 6 minus 6 plus 3 7 ja 21 upon 5. 21 minus 6 is 15 upon 5 is 3. Then the coordinate of y is 3. So dear student, this is the section formula we are using here, and the point of this x and y are written is x is equals to m x2 plus n x1 upon m plus n. Somewhere is m is written m1 and n is written m2 somewhere in some notebooks. So there is no need to worry. Either you may write m or n or m1 plus m2, and sometimes is the ratio is in some question is k ratio 1. This ratio will also you can see in some question also. So there is no need to worry. Either you can use m or n or m1 plus or m2 or k ratio 1. According to situation or conditions you can write. Okay, I hope now the next question is, we will try here. I hope this question is you understand now. The next question is find the area of a triangle ABC. Find the area of the triangle ABC is, okay, 1 upon 2, and the coordinates of a triangle ABC are given here. So I can write here. Okay, I write here this a 2, 3. This is x1, this is y1. Here is this is minus 1 or 0. This is x2, y2, and this is x3, y3. 2 comma minus 4. This is x1, y1, x2, y2, x3, y3, and this coordinate, first coordinate at the last, we can write here 2 comma 3. Okay, now then area of these triangles we already discussed now, so we remove this one very here. Then now slightly we write both at here. Okay, now 1 upon 2 is, multiply this is 2 comma 0, this is 2 into 0 plus minus 1 into minus 4, minus 1 into minus 4 plus 2 into 3, 2 into 3 minus this one. If we multiply bottom to upwards, then we take negative sign. So minus is here, then minus 3 into minus 1 into minus, that is plus. So 3 will come, 3 into 1 will come here. Then here is minus, here 0 into 2, 0 into 2 minus minus plus 4 into 2. Okay, now here is equals to 1 upon 2, 2 comma 0 0 plus 4 plus 6 plus 3 minus 0 plus 8. Okay, now this is, here is 4 plus 6 10, or 10 or 11 21. This is 21 upon 2 square unit. This is the area of this triangle ABC, where wherever x1 y1, x2 y2, x3 y3 and x1 y1 already discussed in this formula in previous lectures. Now this is the our required results. Now the next question is, find the value of k where the coordinates of the triangle A is 2 comma 3, the coordinates of B is 4 comma k, and coordinate of C is 6 comma minus 3, where the area of this triangle is 0. It means the points are collinear. Now here once again same formula we are using here, but in this time their area is equals to 0. Now we are doing next question number 4th here. Here is 3, here is 4. Okay, now we write this coordinate is 2 comma 3, 4 comma k, 6 comma minus 3 and 2 comma 3. These are the point of coordinates. Now area of the triangle, area of the triangle ABC is equals to 0. This condition is given because the points are collinear. Now applying here the 1 upon 2 is 2 comma k, that is 2k, direct I can write 2k, minus 3 to the 3 for the 12, minus 12 plus 6 into 3 18 plus 18 minus 4 3 is 12. Okay, with negative sign, or here is minus, so minus 6k, or minus plus 6. Okay, then here is 12 and 12 24, or 24 1 upon 2. Here is 2k or minus 2, that is minus 4k. Now here is 12 plus 24, 24, or here is 24. This is plus 24 minus 24 is equals to 0. This is cancelled, so this is divide up to minus 2k time minus 2k is equals to 0, then k is equals to 0. It means the value of this k is 0. It means 4 comma 0. Now, if we write in place of k is 0, then the area of this triangle is equals to 0. Now, so dear student, we can practice with more examples in another classes, and I hope you can also do this exercise. Already all the formulas we are also discussed, examples is also discussed. Some questions can be given like this: relation between x and y, like this. One examples we take more here, so that nobody is in. Suppose here is, this point is A, this point is B. The distance of this A, B is 10 unit, and here is the coordinate of x is 2 comma x, and the coordinate of here is y comma 5. Then find the relation between x and y. If such type of questions can be created, but the way of solution is very simple. So you can solve like this: distance of AB, distance of AB is equals to square root of x1 minus x2 or y1 minus, either you can say y minus 2 to the whole power 2 plus 5 minus x to the whole power 2. And here is 10 unit given, 10 to the power 2. Here is then square of this side also, then y minus 2 to the whole power 2 plus 5 minus x to the whole power 2. Then 100 is equals to y square plus 4 minus 4y plus 25 plus x square minus 10x. Okay. Now here is x square plus y square minus 10x minus 4y. Here is 29. 29 is, this 100 will be in the right hand side, so 100 is negative, plus 29 minus 100. Then this is equals to 0 here. Now x square plus y square minus 10x minus 4y or minus 71 is equals to 0. This is the relation between x and y when this 10 unit is given between A and B. So dear students, you can, I hope you can try more and more questions about this exercise. Either it is a distance formula, either it is a area related, either it is a square base, parallelogram base, or rhombus base, and section formula related questions you can do.